Hello. It's nice to see you all again. So please excuse me, this talk was brought together at the last minute to replace a cancellation. Before we decided to create Databricks, we spent a lot of time working with users of Spark. In fact, you could say we cheated as a startup team because we, as a research group at UC Berkeley, spent several years driving the adoption of Spark, bootstrapping Spark, and watching very carefully how people used it and what they needed. We trained hundreds of people through Berkeley in the open source Apache Spark. So when we created Databricks, we had a hypothesis that we were working with about what people needed to make Spark that much more usable. In this talk, basically, I'll digest the lessons that we learned in the first few months of working with actual users on Databricks Cloud with Apache Spark. In the first version of our product, as we pivoted from research group to company and chose our initial MVP feature set, we had a hypothesis that our most obvious and most lucrative customer persona should be data scientist. That raises the question of what a data scientist is. As researchers, it's surely no surprise that we were all full of ideas about what a data scientist is. Obviously, there's no single definition. Before data science, we were talking about cloud computing, and in between the two, we were talking about big data. All of these things mean hundreds of definitions to different people. In fact, in the keynotes that you heard this morning, it means one thing. At a business track of Strata or a Future Spark Summit, it means another. And in a developer track, it means yet another. So as researchers, we made some hypotheses about, we thought about, as we do from in our heads, what data science means. And to derive a definition, we started at the high level, as one would, for the goals of data science. So at Databricks, we said this a lot, to get value from data. It doesn't really mean anything yet. That's a problem. What does value mean? Well, if you zoom in a little, in order to get value from data, you need to transform the data somehow. Typically, in all of your organizations and at Databricks, as we run our product, collect terabytes of log data. That's often the first starting point for transforming the data. So that's the turning verb here. Turn your data into insights. Insights is still vague. Again, all very vague so far. Turn insights into impact is how you take sort of the questions that you've been asking and actually do something meaningful with them. Still very general, but as researchers, it means something different. Maybe you write a prototype and you prove something and you get a paper published. Then we started Databricks, and we learned a whole lot. It turns out that things don't work top-down in corporations. They work bottom-up. So the way it works at a company, and most of the customers that we've seen, especially in the early days when I was working with customers, were that a senior executive somewhere reads about big data and kind of becomes convinced that big data will be necessary for their corporation to take the next step into the 21st century. That executive level person dispatches a technology manager to take care of their big data initiative. The technology manager puts up a job posting for a data scientist. At Databricks, I've actually been trying to hire our first full-time data scientist for about 6 months. And it's really hard to know what the hell we're hiring for. You'd think that as Databricks, we'd be able to have really high bar about what a data scientist is. And to be clear, what we've been hiring for is, and this is not a hiring pitch, but feel free to email me, is somebody who can take all of our raw data from Databricks Cloud, transform it, and have a regular running pipeline, and then give us some insights. And those insights go to our business team. They go to our sales team. They go to our executives. They go to our customer service team. They go to our product managers. This is actually basically what it looked like at Databricks, except these were all squished into 1 or 2 people. And that's how it looks at startups as well. So what does the data scientist do? Let me see if I can get the clicker to work. Great. What we've seen in our customers and what we've tried to reproduce inside of Databricks as we dog food our own data science is that the data scientist is hired and given this general charge, 5 bullets on this slide. First, figure out what the internal customers of your company needs to deliver something more meaningful based on data. In the first few customers at Databricks, we didn't actually measure how the customers were using our product, believe it or not. So we would have phone calls and emails and read and relate IQ about what's going on. We talked to I went and sat with a bunch of customers, and I would report back at all hands, hey, I think they're using it today. And you would imagine that since we built this thing from ground up on the principles of data science for data scientists, we maybe would have had some monitoring and some measurement. But we didn't, because it just wasn't in the critical path to get Databricks Cloud out the door. So as one of Databricks' first data scientists, and you'll see that if I call myself this, it's not because I know a lot of math. It's because I'm using one of the particular definitions that I'm kind of developing here, a working definition, is that I had to, given Jan's charge, to make Databricks data-driven, I had to pick some metrics. And so for us, this was customer activity. How many times are people clicking through the Databricks Cloud interface? The data scientist, then now having some metrics that he usually meets with some product managers, executives, salespeople about, decides how he could, whether he can or she can even derive these metrics from the data that's being collected. By the way, for number 2, often the answer is it's not possible yet. So you need to go back to engineering, have them add some more logging lines, and then do the data cleaning and transformation thereafter. Once you have an idea that the log lines exist or some other sort of data exists that you need to use, then it's a matter of cleaning it. There's whole startups, for instance, Trifacta, surrounding the data import, data cleaning phase. And we've spent a large number of features inside of Databricks Cloud to help with this. For the data scientist, explores the data that has been cleaned, probably turned into some sort of SQL queryable table. And finally, they think they have something that will provide value and can drive decisions inside the organization. And maybe 4 is running a bunch of machine learning algorithms. 5 is taking what you've currently built before Databricks Cloud and in the real world. We see all sorts of versions of 4, and then usually a pretty drastic shift from 4 to 5. And so there's a big invisible line between 4 and 5 here. And this line, to me, represents the difference between ad hoc exploration and operationalizing the product, what we call a data product, or what I've started to call a data product. And these two sort of tasks actually require 2 fundamentally different skill sets. Not to say that a single person can't have both. And in fact, sort of the unicorn data scientist is able to do both. I've started to call these things data science and data engineering. Again, any definitions I give here are not real, so please feel free to forget them. But just for the purpose of this talk, I'll use these 2 words. Now let's zoom in on data. Well, let's kind of forsake what I say here and say that there are 3 types of data scientists, one of which is the data engineer. So I'll call them the data explorer, the data engineer, and the ML specialist. In reality, through dozens of customers of Databricks Cloud, these 3 personas seem to fit really well. And they allow you also when hiring, I've phone interviewed dozens of people for the data science position, which Databricks recently renamed to data engineer, because we decided that we actually want somebody who creates a reproducible, testable, continuously running, low latency, high SLA product, that being our ETL pipeline. And a lot of the math people that I interviewed just, they could do some of 1, a lot of 3, and I basically just started in my interviewing process coming up with questions that helped me just weight these 3 bullets for each candidate that I talked to. And in reality, it's really nice that it matched my instincts as trying to hire a data scientist with the feedback or the model. This model actually we built while we were sitting with the first 10 to 12 customers of Databricks Cloud. And what you'll see in the later slides is I'm going to go through each of these personas. And for each persona, I'm going to give you kind of the high-level stats, what the profile of the person looks like, and then the workflow that they use. So before we do that, let's just skim through all three of them. I'm not trying to make this a product pitch for Databricks Cloud. You have a lot of that at this conference. But I am trying to give you a sense of what the feature set that we ended up driving into Databricks Cloud what was in reaction to the profile of each of these personas. So the Data Explorer, as I call this person, their objective is to prototype, explore, collaborate, and share. You can think of this person, probably a grad student with a nice mix between engineering and so like CS principles and math, and maybe some internships at a company that's taught them something about continuous integration or testing. They're not in a strong position in this role, and it's not required of them to harden this thing. And also, they should be aware of what error bars are and kind of be able to give you a sense of error bars, but usually it's fast and loose in this world. So what feature set would you want in a product? And this is not just Databricks Cloud specific, actually. We built the workspace. We have notebooks. This sort of person likes to work in SQL, probably knows SQL very well, also very likely knows Python or some other kind of high-level language. They want to iterate, get results, graphs out to their manager, probably report out each week at a stand-up on the current iteration of the exploration. And yeah, so I think that gives you a sense. Overview of the data engineer. Their objectives are very similar to the data scientists. So I'd say that they often have a superset of the skills of what I would just call a data explorer. So sorry, that should be data scientist. It's an old version of the slides I didn't fix. Prototype, which is the same as the data explorer. And then take it one step farther and turn it into production, which means give an SLA, in the case of Databricks, internally, put a big TV on the wall, pay a task, grab it, please hang this on the wall, because there's only 7 of us here right now. And put the browser on. I wrote an Apple script that refreshes the browser every 5 minutes, and it showed a notebook or a dashboard, depending on the phase we were in. And there I was. I had productized something, and I realized, as our temporary data scientists while we're hiring, that the graph I put on the wall was fucking hard to keep on the wall. Our uptime was probably like 15% for the first 3 months on Databricks Cloud, by the way, because we dog fooded it. So it's part of the problem. It was like we didn't have real customers yet because we were so early, and so Databricks Cloud was broken all the time. But it's not just Databricks Cloud. And this was many months ago, by the way. It's not broken all the time anymore. Everybody has this problem. When you go from exploration to operationalizing your data, it's hard. And you need to hire ops people. This is a whole very hard to find skill set in the Valley or in anywhere on the island right now. So yeah, prototype, QA, test, maintain, cut releases, version, features that people wanted in their product. They want to use, and by the way, Databricks Cloud doesn't even have all of the things people are really asking for this right now. Because they're an engineer, they typically use IntelliJ or some Eclipse or their IDE of choice. They really need Git. Databricks Cloud, it's on the roadmap that we put these things in, but there are solutions out there. They're going to want to use Git. They're going to want to use unit tests. They're going to want to use Jenkins to do continuous integration. And they're going to need RPC calls or some REST interface to kick these things off from some internal workflow manager and put the results somewhere well-known and rerun them like if things fail. This person is an ops person, essentially. But they tend to, in order to kind of get hired into the data engineering role, which is oftentimes just called data scientist, they tend to have kind of forsaken their kind of shell hacking obsession and like started to be obsessed with data. So it's like a classic network specialist who, or like ops person who now like loves data because they still have to understand what the data explorer is doing. They get handed this list of notebooks or maybe some models or something, and they really need to care about operationalizing this. All right, so the machine learning specialist, this one's not too hard to figure out. It's probably what I think a lot of people in this room, can you raise your hand if you're in this room because you actually like are thinking about the math side of machine learning or of data science? Okay, great. So you're all probably pretty upset that I'm talking about all this business bullshit. Apologize for that. But you all, really important part of this talk, you all are, those of you who raise your hands, are essentially charged with, in addition to kind of understanding how the other pieces work, and many of you are almost certainly going to play multiple of these roles, the core functionality of this pure version of the role is to take the data, train a model, get the parameters, hyperparameters, featurization, hand over that model to somebody, unless you're playing multiple hats here, hand over that model to somebody, and you've done a job. You know, you get a raise. If you pick the right model, that's what we're or you all are interested in, is the math side of it. Recommenders and regressions, and this is a very particular type of breed. And what we found is that oftentimes the biggest divide between these different roles is between this and the other roles. So you find somebody who has like a physics background or applied math or some other math degree, and they're looking to become a data scientist, and that's great. They can work in MATLAB, but probably not in explain what a shuffle is. So that's the distinction. All right, let's zoom in a little. The point of these slides, again, the whole idea of this talk was the real world, because I sat with a bunch of customers. I brought back an early version of this slide deck to give it an all hands almost a year ago. And the next 9 slides, 3, 3, and 3, I think, actually had pictures on them and real people's names and companies' names and the description of the company. So they're Databricks customers, and I've tried my best to anonymize them, and if I fail, I apologize to anybody at those companies in this room. We essentially just took a snapshot of what our customers are doing, and this is what led to the profiles that I just described. So the Data Explorer, a video delivery company. The team's name was Data Science. The toolbox is Hive, SQL, and Excel. And they have essentially 2 very large Hive tables, one much larger than the other. And you can think of this as like the fact table and some auxiliary tables, and pumping in many terabytes a day. The user profile of the Data Explorer there. So their output, what they produced as a Data Explorer, are internal and external. They're delivering to internal and external consumers, which means some of the customers themselves had questions about the performance of the video delivery system. And so they'd say like, hey, our videos are actually going slower than we think they should be given your video delivery system for us. Can you tell us what's going on? And so their data scientists would be dispatched, Data Explorer, to actually go and poke around and say like, oh, there was a CDN down, so that explains it. Or there's a bug in our algorithm internally. And the results were then actually PDFs that get emailed out to customers. Similar thing for internal deliverables. PDF or PNG getting shot off in an email, oftentimes a CSV. Ad hoc, iterative information finding. An interesting thing about this is that they typically are trying to answer questions that probably have an answer. And I think I said they're deliverables, CSV files, Excel spreadsheets, a lot of email. This is what, just as a side note, drove us to like make Google Doc-like comments inside of notebooks in Databricks Cloud. Their workflow import, okay, so this is a Databricks Cloud workflow, import data into your system, do a bunch of ad hoc exploration, analyze and mark it up as you go, and then maybe create a dashboard, maybe download the notebook as HTML, or maybe just save a PNG out of it, somehow share it. So this could be, if you're using IPython notebook, actually export the notebook and email it over to somebody or post it on your blog. All right, second profile, data engineer. This was an Internet of Things / wearables company. Team name was Data Products. They used Python, especially pandas was their favorite part of Python, and matplotlib, so these are all Python things. And they have lots of JSON data already sitting in S3. They are internal customers only, and the thing that they built was a pipeline, an ETL pipeline, what their team called Data Products, which we started calling Data Products after that, that essentially engulfed both the ad hoc exploratory phase and the operationalization phase. So the engineers, the team members' names on this 4 or 5 person team were data engineer, if you look on their LinkedIn. And they didn't actually email out any graphs or create dashboards. They actually dropped their ETL pipeline, which is a schedulable job in Databricks Cloud now, runs every hour or 3 hours, depending on the pipeline, and creates data, so large files in S3 that are, can be ingested by another system. In particular, one of the systems is their customer engagement system. So a customer phone representative has a little flag set on their screen when a phone rings and they pick it up and they get an account ID for this wearable, and they say, please put it in the mail right now. Don't even need to talk to you. Because the output of this pipeline was something that helped identify likely failures from a known hardware problem. So the key here is that they're not delivering some insight yet. They're delivering some transformed version of data that allows that's ingested into some other system inside their company that then derives an insight. That insight being cost savings, because it turns out their phone call center is even more expensive to run than the hardware that they're shipping in this IoT thing. So prototype, the analysis, that's essentially do what the data explorer does. They use graphs along the way, but in the end, what they get is sort of like some JSON or CSV file or some simple SIRD Hive tables. QA the analysis. This takes, so 1 is actually really fast. 2 is the hardest part, I'd say. And we do this at Databricks too now. We actually have this ETL pipeline. Remember I said it started at like 15% uptime? I think we're up to like 65% uptime or 75 right now. And that's partly because I haven't found a good data scientist yet. So send me the emails. Prepare the output and input streams, and then set up test and operation, like deliver on. So get PagerDuty installed and wake up at 3 a.m. to try and keep those graphs on the wall. Data product built. They actually have built a handful of data products. The battery life comparing so these each started as an ad hoc exploration and resulted in some output data set that gets updated every night. And theoretically, not all of them are yet getting ingested by the other central points inside their system, but many of them are. So this could be, basically roll-ups or summary tables that are getting generated as part of the ETL pipeline, like the activity graph, which might be actually generating directly a dashboard on the wall. It could be something like the battery life versus the error logs that we were talking about earlier. So maybe that data is dumped. That's the one where it's dumped in for the customer system to pick up for customer reps in the phone. All right, the machine learning specialist. This was a crowdsourcing company that we were working with. Team's name was Data Science. Looks like a pretty typical kind of toolbox for the math type. Weka, liblinear. They were using Spark, some already. They had large text files. They weren't actually CSV. They weren't actually JSON. They were some weird hybrid of the both. And a bunch of green plum tables that they needed to join up. internal customers only, data feature exploration. This is like, you know, the inner loop of a machine learning specialist. Featureize your data, select the model, you know, build the model, deliver the model, iterate. I think we covered that. So in conclusion, the high-level lesson that we learned, kind of to take it back to the beginning, was with Databricks Cloud, or with Databricks, our hypothesis was sort of, what does insights out of data mean? And we're going to have these data scientists and engineers. You know, if you've seen the demos for Databricks Cloud, you all have access to it. We think that people with programming skills, sort of like the ante, is what we bet on. That people with programming skills will be a large market. We had some ideas about what data scientists might do from the top down, but actually going out and sitting with you all, I guess, was the way that we evolved to this pretty simplistic model of there's these 3 types of data scientists, which I call data explorer, data engineer, and machine learning specialist. And really, as you hire or as you think about what you want to do inside your organization as you build out your data science team, I would love to hear from you, or I would, you know, be honored if you find some value in this model of kind of keep in your mind the simple divide between these 3 things, and also that there can be like a weighting between each of them. So somebody can be 70%, 10%, 20%. That's it.
Couple questions?
Yeah. Over here.
You said that one of the purposes of the data engineers was to operationalize well, I guess I'm not exactly sure which part of it you meant operationalize, the whole shebang. Do you find that in a lot of installations they are also maintaining the operations, or is that a separate role entirely? That's one of the benefits I see out of Spark, is that because the operation is much simpler than previous big data, that potentially I can have the same person do both. But I'd love to know what you've seen out there in the world.
Yeah, I'd say pre-Databricks Cloud. So there's two versions of the answer. With Databricks Cloud, in the last like 4 months, we've added features that we think that have been asked for by the users of Databricks Cloud. So there's the Databricks Cloud answer, which is we added a whole set of features, a thing we call jobs, which essentially lets you run a notebook or a jar on a cron schedule, and it has a bunch of features like having your email sent off if the job fails with an error code, and you know, like a limit on how long it can run before it kills itself, whether you want to use spot instances, all these things. That's a set of features that we drove so that the same person, so basically to make the data engineering work easier and more in the domain of like somebody who could be both without actually having to hand it over to an ops team. Outside the Databricks Cloud realm, so in the world before when we were sitting with customers, and even when we're still working with new customers, you see both. You see some more mature organizations where the ops team is capable of being handed something like this. So this is often like the Python pipeline, or frequently there's a rewrite between the exploration and the engineer or the product, operationalization. So the data explorer prototypes out something on a single machine, either in R or Python, hands it off to the engineering team wherein ops is involved and actually maintains the SLAs and delivers the full operationalized machine and has PagerDuty and everything set up. And that handoff usually involves like Python getting rewritten into some JVM-based thing, or some more like, maybe not necessarily, but like at least often major pieces of it getting rewritten. In startups, it's usually like the same team. So, does that answer your question?
Yeah, for sure.
One more? Is that it?
I think I won this one by virtue of being closer to the microphone. I mean, you mentioned that you were looking at data scientists and then decided that what Databricks needed was data engineers. And I realize I'm characterizing how you explained it. It's in the interest of keeping my question short. Now, there's a good job that Databricks has done looking at your pull requests and taking care that this was good software engineering, including covering the edge cases, making sure that algorithms, especially contribution for lib integrated with the whole system, etc. there's also a challenge into making sure that machine learning implementations, as they are going indeed to come to MLlib as pull requests, integrate on the mathematical part of things. Do you see that there will be a challenge into evaluating those pull requests in the mathematical side? Is Databricks going to invest into data science purely to do that? Or do you already have enough support, do you feel, from the community?
We do have a number of extremely intelligent data scientists in the math side of the world that are leading the MLlib effort inside of Databricks. So if you find Sean Ray, Meng, or Joseph Bradley around here, those are two of our data engineers, or really they're software engineers at Databricks that are leads of the MLlib project that have the technical and mathematical chops to validate the actual math behind what's going into MLlib. Though, as you've observed, MLlib is at the phase right now where the bottleneck is primarily engineering work and not validation of the algorithms, because the algorithms aren't advanced enough to require that high level of validation. So I guess my answer is, I'm not one of those people. I'm not one of those on that team even, but I do know Sean Ray and Joseph well, and I have confidence in their ability to kind of handle the evaluation and analysis of the actual math going into MLlib once we get there.
For sure, but it was more of a scalability question. You're receiving an awful lot of requests.
About scalability? Yeah, let's talk about it offline. I think that we're always trying to make the Apache way of doing software more scalable. We think we've done a decent job with a variety of components inside of Spark, and probably MLlib, as you pointed, I think what the point of your question is that it presents a new type of challenge to this sort of model, and so we're open to a lot of feedback if you have some. Thank you very much.
Thanks.